So we're going to be doing the NaCl standard curve solution scheme lab. So the first thing we need to do is gather our supplies. And we'll need a 100 milliliter volumetric flask, 50 milliliter volumetric flask, and then two 25 milliliter volume flasks. And then for part 2 of the lab, we will need this 10 milliliter volumetric flask. So the first thing we need to do is pour some sodium chloride into this beaker to make our standard solution A. And then A will be used to make all the other solutions. So it says 0 a 50 milliliter beaker on a balance. So here's my 50 milliliter beaker. Put that on my balance and then zero it out. Great. So I spilled a little bit on the balance. I'll get a brush to sweep that off so it doesn't affect my mass. Oh, a little bit too much. Anyway, that's 16 grams. Close enough. Before we record the mass, we should remove that, because that's not going to be part of our mass. All right. So, in case you can't read that display, it says 16.0599. Good. All right. So that's all my salt that I'm going to be using to make this solution. So I need to transfer it in here. To do that, I'm going to wet it to make like a slushy, a very salty slushy. I won't be able to get it all in one go, but I'll try to get whatever I can out. Yeah, I didn't get very much. Very important not to spill, because we want all of that salt to end up in the flask. Rinsing the sides off to make sure it all ends up inside. Looks pretty good so far. Okay. I'm going to give it a little swirl now to get it started dissolving, but soon I'm going to have to fill it up to the line, that line. Only one line for this volumetric glassware. Okay, it's starting to dissolve. I'm going to fill it up more, give it some more water. And do a pre-shake. Important to cover the top. When you invert it. Now when all that salt's really dissolved, it'll be clear. So we'll just keep inverting for a while, mixing it all up until all that salt dissolves. Okay, I'm still not up to the line with water. So I'm going to add some more water until the bottom of the meniscus is right on the line. That looks good to me. But as we shake it up, the solution gets more dense, so it might be below the line once we get it fully mixed in, and then we'll have to add a little bit more water. You can see it's getting more clear. And yeah, you can tell that we're just a little bit below the line right now. Maybe a couple drops. A lot of little air bubbles on the side. Okay, I'm just gonna add like one more drop. Okay, back up to line with water. All right, so now we have made solution A. So you should have recorded the precise mass of sodium chloride. And now you have enough information to record the molarity of solution A. And as far as significant figures go, for volumetric glassware, it's very precise. So that's really 100.00 milliliters. So keep that in mind. For all of these volumes, there's really 2 significant zeros behind the digit you see in that table. That's important. All right, so we're going to be using solution A to make solution B, C, and D. So the next thing in my procedure, it says we're going to make solutions B, C, and D as described in the table. And so it says add the volume of solution A indicated in the add row, and then dilute up to the mark with DI water, and then mix it up. So to make solution B, we need 25 milliliters of solution A. To do that, I'm going to use a 25 milliliter volumetric pipette. So I'll take my solution A, my solution B. This is a pipette pump. So pipettes are a lot like straws, and you gotta make sure you suck into the straw rather than blow out. So there's a little bit of water in that pipette that we'll pretend wasn't in there. Okay, so I can scroll up to increase the volume. Whoa, air bubble. I got an air bubble. Got a few air bubbles. Gotta keep my pipette in the flask so that I don't suck up air. So I'm using my thumb to scroll up on the pipette pump. And I'm trying to scroll up so that the bottom of the meniscus is right on that line. You see it? Right on that line. Great. So now that's on the line. So I can take this out, put it in my solution B, remove the pipette pump, and let it dispense. So that I don't spill my solution A, I'm going to put the stopper back on. So we have to remember that, again, this is 25.00 milliliters being added into this flask. Now we're going to fill up to the line with water. Okay, so it's filled up to the line. Bottom of the meniscus is on the line, and so I got to shake it up. So now you have all the data you need to calculate the molarity of solution B. We are done making solution A and solution B, so you can calculate the molarity of both of those. Now we'll make solution C. Solution C says I need to add 5 milliliters of solution A. So I need to go get a 5 milliliter volumetric pipette. 5 milliliters. Eye level with it so I can see that the bottom of the meniscus is at the line. Great. Okay. It looks like there's a little bit of solution left in the pipette, but that's okay. It's meant to deliver 5 milliliters, so I don't need to squirt that out. Next, I'm going to fill up to the line with water. Gotta add slowly so I don't overshoot the line. There we go. So Now you can calculate the molarity of solution C. All right, last up we have to make solution D, and in this one we're going to have to use 2 milliliters of solution A. So I could have grabbed all my pipettes at once, but I'm not going to. This one is a 2 milliliter volumetric pipette. So we're going to take 2 milliliters of solution A and put it into our D flask. What's nice about the pumps is if you overshoot, you can control it a little bit better. Sometimes it can be tricky to get right on the line. Okay. Looks like I got an air bubble in that one. Oh well. Okay, so we've put 2 milliliters in there. So now we'll fill up to the line with water. Great. So the bottom meniscus is on the line, and then I can shake this up. All right, so we've made all of our standard solutions, and so you can calculate the molarity of solution D now before we move forward. All right, now we're ready for part 2 of the lab. In part 2 of the lab, we need to calculate the densities of all of these. So the first thing we need is a clean, dry 10 milliliter volumetric flask with stopper. And so we have to record the mass of this clean and dry. So with the stopper. So the mass reads 17.9739. Oh man, I touched the button. I didn't mean to touch the button. Okay, it says 17.9726. Okay. All right, the next thing we need to do is we got to fill up this 10 milliliter flask with water. The water is from the tap, so that's our deionized water. There should be no salt in here. So filled it up to the line with water, put the stopper on, and then record the mass of this flask containing water. And so that reads 27.920. Well, I'm going to let it I'm gonna let it finish moving before I record anything. All right. All right, seems so settled-ish. Stop moving. 279212. All right, so that's my mass of my flask with deionized water. So I can dump that down the drain. And the next thing I have to do is record the mass of the flask with my solution A. So I'm going to take my solution A, and I have this transfer pipette. And that's not quite long enough. No, that's not quite long enough. So this says 10 milliliters on it, but I'm not really using it to transfer 10 milliliters. I'm going to still use the line on the 10 milliliter volumetric flask, but I'm just using this to get approximately 10 milliliters out. I'm going to overshoot a little bit. I was just using that to get the solution out. I'll still follow that line right there, and I'll use this to remove the extra. Okay. So great. So now that's filled up to the line. So this reads 29.0934. So that was my mass containing solution A. So now I have enough information to calculate the density of my DI water and the density of my solution A. Since that solution A did contain a lot of salt, I'm going to rinse out my flask with water. I'm going to need more water though. Okay. All right. Now I can measure the density of solution B. Let's see if this is long enough now. Okay, so that's filled up to the line with solution B. Come back over to the balance. And now that says 28.09 28.579, stop moving, 93. And again, I need to rinse this out with water to make sure there's no salt residue in there. Great. All right, that was solution B, so now I can do solution C. Yep. I think I like using the volumetric pipette a little bit better. Yeah. Overshot, but I'll just remove this until I get down to the line. There we go. Gotta make sure I use the right stopper so that my masses aren't screwed up. I've been using this stopper for the densities. All right, so this mass says 28.23 of the last digits. Taking a little bit to settle. We will call that 23.2310. Okay, so that was my solution C. Again, rinse this out to get soap, not soap, but to get the salty out. Gotta rinse out the salt. All right, now for the last one, I'm gonna use, this kept getting stuck. So I'm gonna use this to suck up approximately 10 milliliters. That fits a little bit better down the neck of this thing. Again, I'm not using the pipette to precisely measure. I'm using the line. I'll just let that dispense. Now I'll come clean it up. All right, so wrong stopper. This is the stopper. Okay. Give it a moment to settle. And it says 28.1186 or 85, either one. Won't make that much of a difference. Okay, so you have enough information right now to calculate the densities of all these solutions. Remember, we only care about the mass of the solution inside the flask and not the mass of the glass. The mass of the glass is not part of your density measurement. Okay, so I have all of those. Now the whole point of this experiment is to calculate the density or the molarity of an unknown by comparing densities. And so I have this solution U here, unknown U, that I will now use to fill up my 10 milliliter flask. Let me try to shake out that little bit of water. There we go. That's pretty cool, but not what you're supposed to do. It formed a meniscus air bubble. Okay, I overshot the line a little bit, but that's okay. I can just take a little bit out. Great, so now it's right on the line. I can put the stopper back on and record the mass. Okay, so the mass says 28.2531. So I have enough information to calculate the density of my unknown. Okay, so I can calculate all of those densities. Make sure you do not use any part 2 data for part 1 or any part 1 data for part 2. Those are separate parts of the lab. After I do all those calculations, I can summarize my calculated values in this table and make a graph using Microsoft Excel. There is a separate video on Canvas about how to make a graph using Microsoft Excel. There are some instructions in here. You will need the actual software program, not the web version of Excel. The web version of the app does not allow you to make an equation of a line. So you will need to use the actual software.